Hi, I'm Matt with Scalable, and today I'm here to talk about event-driven architecture, specifically as it pertains to building your own search engine. So a lot of people don't realize this, but when you search a search engine, they use pre-built indexes. So when you go to Google and you type in your search, it doesn't actually go website to website to website and come back. Google already knows what the results are for each individual search term. This video actually stems from a post I actually wrote for the Bootstrap founder. He's got a podcast. You should check it out. It's pretty cool. He was working on a search engine as well. Designed several very scalable search engines on AWS and still currently designing them. And this sums up a lot of what I wrote in that post. So hopefully this can be helpful to you. So let's just start off. First, let me show you the problem. By the way, if you haven't seen my previous video on event-driven architecture, you should probably watch that first. Additionally, I've got some videos on AWS Glue, which I'll be referencing later, so that's a good one to watch as well. So here we have your infrastructure, and just imagine Kinesis isn't there for now, but I use the same diagram. We're just ignoring that for now. The user sends a request in to search, saying, hey, I want these products with these filters. I want all the red shoes that are size XYZ in this brand. So you might be using a cache system already. In this case, you've got, you cache all the products for shoes X, Y, and Z. But let's just say you're expiring them every 24 hours or every 2 weeks, you expire that cache. So let's just say, yay, it's cached right now. And by the way, this is my makeshift software, my network diagramming software. Still working on it, so bear with me. So we go ahead and respond with the products because they were cached, and that was actually pretty quick. He gets to go around, continue browsing, maybe buy some of the stuff. Great. Alright, so the second time we're going to simulate it as if it wasn't cached. So he sends his request in. He wants to get all the red shoes in size 13 or whatever. And here it is not cached. So then the application server has to go ahead and query the database. Now some of you guys might be like, oh, I've got indexes on my database. That's great, except at the scale we're talking about, it doesn't make sense to have the indexes on the same hardware as the database records. It just puts additional load on the database. So we actually will keep, in this one when we get to it, we'll actually keep our indexes on a shardable separate set of hardware, specifically Redis. I'll show you in a minute. So either way, they go ahead and run that expensive query there. You saw the server suffering. And it caches the response in Redis. So it then caches for the next 24 hours, 2 weeks, whatever you set your TTL to, and then responds. So you might wonder why you'd expire the TTL. Well, in this scenario, they haven't developed a way to update those indexes, and that's what the whole concept of pre-built indexes are. So finally, after all that, the user gets what they're looking for and hopefully is still around to buy more stuff on your website. So that's how you don't want to do it, all right? What you want to do instead is you want to pre-build your indexes. So let me show it. It's a two-parter because you have to, when a new products come in, you will pre-build the search indexes for those products. And those products, the index might be all the red products, all the green products. So you could have products indexed by color. You also could have products indexed by size, products indexed by type, etc. And it's a bit beyond the scope of this one, but using various Redis commands, which I did write up in that post, which I will try and link in the show notes. So the tricky part about this one is when you pre-build your indexes, you have to actually, when the new record comes in of a new product, or when a product gets updated, not only do you update the database, you have to update all the indexes that are relevant. So this is the admin. Let's just say this is someone that works in your product division and they're adding one new product, or that could be 100 new products. Doesn't matter. It's a fairly similar process. They go ahead and send the requests to your application server or admin cluster if you cluster off your admin, in which case that will send a create message to the new database here. So the database says, all right, I'm creating a new product. Now, you actually could do this afterwards if you don't need a database ID back. So for example, if you're using something like DynamoDB and you send it the ID that you actually want it to have, the specific pre-generated ID, you can actually create the record afterwards. That's fine. So either way, that then broadcasts a Kinesis event. The Kinesis event is basically all the product information that could be consumed by other workers. And again, Kinesis is not SQS. It can be consumed by many workers. So in this diagram, for our sake right now, I've only got the product service worker. But it could be consumed by the inventory worker, the sales reporting worker, etc., etc., many workers at once. So once the application server broadcasts that product information to Kinesis as an event, it can then go right ahead and respond. And again, it wouldn't have had to save to the DB technically first, but it's not a bad idea to do that to make sure there's no conflicts here. But it basically at that point would want to return the new product ID and whatever information was created there to the admin, and they can get a cup of coffee, I suppose. At this point, we're going to jump back to Kinesis, where the Kinesis event is available for any of the consumers that choose to consume from it to grab that event and start processing it. Here it tells Redis to update the appropriate indexes. So, it's going to add it to the color red. It's going to add the shoe to the shoe index. It's going to add it to the size 13 index. It's going to add it to all those different things. And there it goes ahead, and Redis will then update the key value pair. So this would be like an S add or a Z add if you're doing rankings. So you add it to the appropriate indexes. If it was a delete of a product, same thing, you do an SREM. Make sure you've got a unique key for it, and that unique key would probably be the globally unique ID of the product. So then after that, the product service worker could be the same product service worker, or you could have an inventory worker or something like that say, hey, I've got a new product. I'm going to add it to whatever we use to manage our shipping. So for some of my clients, they have third-party integrations with shipping software. They don't run their own software for that, so then it goes ahead and adds it to that. And maybe you even, I don't know why it's going to the mail service. Hold on. That was the adding the product side to the search engine. And it could be products, it could be websites, it could be animals that you're keeping inventory of. It could be any number of things. So it does not just need to be products. Anything you want to search for, your customers want to search for very quickly. That's what it needs to be. So now let's look at how the customer side of the equation changes when we use pre-built indexes in event-driven architecture. So let's examine the customer flow here, okay? So the customer comes to your website, they put in some filters. I want to see all the red shoes that are size 13. And so in which case we go directly to Redis now. We check to see if the key exists. If the key doesn't exist, then we don't have that product. There's no product line. Something's wrong with the filters most likely. That, or you got filters that you don't have any products that match the filters you've got. But we go ahead and respond with that, and it never really hits the database. There's no MySQL queries saying find where shoe like red, and don't use like statements in your SQL if you can help it. At least with your customer facing stuff, you should be pre-building the stuff when possible. I know I'm going to get trolled for that, but troll away. Leave a trolling in the comments if you want to. At the end, they buy more stuff, theoretically, because that's lightning fast, split second. There's two things I got to address, though. Okay, so just because we have the IDs in a pre-built index, that say here's the IDs of all the red shoes, doesn't mean we have the title or the images or anything like that. So you could do it, so when they get done with this search here, the application server runs a query, a very efficient query, against the primary source of truth database to say, hey, give me the backup information or all the details by ID for like all these products by ID. So like here's to paginated, obviously. So give me these 100 products by ID, which is very efficient as opposed to string searches or random field searches. In which case your primary database could respond, or since your primary database probably has a lot of data on those items, metadata or things like that, those products that don't need to be public, you can cache those products in here in Redis if you'd like to. And you're like, oh, why? I'm just grabbing more stuff in Redis. Well, Redis is insanely easy to shard or partition, basically. The same thing, just using different verbiage there. But because it can only be looked up by the key, and only ever the key, which would be the product ID in the case of caching the products, it's real easy to do this. So I would just cache it in there. Another option is DynamoDB, which basically it's really tough to query by things besides the partition keys in there. I mean, it's doable, but I wouldn't recommend it. So that's an option right there. I wouldn't cache by the value. I tried that one actually. I learned an important lesson there. Don't make the value in an S members or any Z members, S members more complex than just the ID, because if a field changes, like let's just say someone screwed up and they changed the title of it and you had like a JSON blob that held not only the ID but also the name of it, it's not going to find the older entry to remove it. It needs to be by basically an immutable ID. So don't do that. Learn that the hard way. So that is pre-built indexes for your search features on AWS in a nutshell, using event-driven architecture. Let me throw some more buzzwords at you. No, I'm kidding. I went pretty fast on it. I didn't go into the specifics. Feel free to check out the post I wrote on that. I'll double check that that's in the show notes and try and polish that up. If you like this and you want to learn more about this, I'm actually considering writing another ebook on designing AWS scalable search engines and search features. I know you can run a lot of these different like Elasticsearch and things like that on there. I've never found them to work well enough and scale. I've never seen those scale the way I'd like to see them scales for millions and millions of searches a day. And I do have clients that are doing that. So with that said, I'm Matt from Schematical. You should check out schematical.com/free if you want to see the free ebook course, all the open source Terraform scripts that'll get you started on this. I don't have code to make the worker happen though, so I figure that people are somewhat language agnostic there. Maybe I'll write one. Leave a comment if you want one, and maybe I'll whip one up and open source it for you. Without further ado, I'm Matt with Schematical, and thanks for watching. Have a great day.